So in the last video on factoring in algebra, we saw how 2x squareds plus 4x's minus 6 could be broken up into two groups, where each group is x squared plus 2x's minus 3. So we factored 2x squared plus 4x minus 6 into 2, the number of groups, times x squared plus 2x minus 3, the size of each group. Now in that video, I stated that you're going to have a really hard time taking these algebra tiles and making a rectangle to factor this using the area model method. I lied a little bit, it's still possible, but it's not as easy as some of the others we have seen. Think about how we might go about making a rectangle and tying this back to that area model. So if I try to place all my tiles in here, I can try to line them up. Maybe I am trying to make a rectangle, but that doesn't work. It's not going to work if I put those over there. If I spread them out, I'm going to just really struggle to make a rectangle. And what we know basically, because we've started doing this a little bit more, is that we're going to have some sort of x term and some sort of number term across. So we need this x squared, and notice I'm just doing one of these groups right now. And then we'll go back and do the two groups together as well. But I'm just going to do one of these groups because now if I can split up this x squared plus 2x minus 3 in a rectangle, I can just put those two rectangles together, really. This x squared is going to have to be x times x. So I know I'm going to need an x times an x. And I know to get these negative ones, I'm going to have a number times a number. And that the x's, and we've started to see this pattern, the x's are going to have to go in these two sort of off spaces. So I know that the negative ones, we've started to see this pattern a little bit. The negative ones have to be sort of their own rectangle, the number times the number. My x's, well, they can go there. Maybe one of them could go across here, but if I do both of them across, then I'm not going to be even with the negative ones. Let's put them back vertical right here. And what I want to show you is one of a couple of tricks that we often use in math. Often in math, we will either add 0 or multiply by 1. And what happens when we add 0 is we don't really change the value of what we're talking about. But by specially choosing what each of these looks like, either the plus 0 or the times 1, we can change not the value, because we added 0 or we multiplied by 1. We don't change the value, we don't change the amount overall, but what we change is what it looks like. So what I'd like to do here is to add a 0 pair. So I'm going to add 0 in. Now my 0, I don't change the overall, but what this 0 actually looks like is a positive x and a negative x. This 0 is made up of a positive x and a negative x. So instead of adding 0, notate that properly. X squared plus 2x minus 3 plus x minus x. And what I can now do is I can take that 0 pair, this x minus x, and I can split them up and make my rectangle. Remember, they were just equal to 0, so in reality I didn't add anything. But I added a pair of items that fit those spaces perfectly that total up to 0. And I can see now that I have x minus 1, so x times -1 is the opposite of x, and 1, 2, 3 plus 3 along the top. And I've just factored this into 2 times x minus 1 times x plus 3 by adding a 0 pair. If we didn't factor out that common factor, that 2 first, put both groups back together and try to come up with a rectangle. So we're going to have 2x squareds. They have to go together. Let's see. We're going to have to do something weird here. There's some x's. I guess maybe, what can I do here? That's not quite going to work. I can rearrange them, and if you play around enough and you start saying, well, what can I do to fill in? Let's make some empty spaces here where maybe I can use some 0 pairs. Here's a 0 pair. Let's pull in another 0 pair. Right? So I'm going to split those 0 pairs apart into their x and -x. And I can nicely now, even with the whole group together, even without factoring out that 2, find a rectangle. But it required my going back out there and finding 0 pairs that fit exactly in that space. So now I have across, I have an x, it's x plus 3 across, and 2x minus 2 down. And so I have this factored yet a different way, because my 0 pairs, because what I added in, these extra blocks that I added in, pair up to be 0 pairs, because they match up to be 0 pairs and subtract each other out. I end up with yet another way of factoring this, x plus 3 times 2x minus 2. There's one more way we could factor it. I'll leave it to you to try to see if you can envision how these blocks would look. But we could have gone 2x plus 6 times x minus 1. So can you see how you might put these blocks together to create that rectangle? 2x plus 6 times x minus 1. And finally, the last thing you could do is you could go back and you could multiply. Multiply these so that we get them back into standard form, and you're going to see that no matter which of these you pick, you're going to end up back, if you do all the simplifications, back up where we started. This is Bit Bath Teacher Barbie, showing you how to use 0 pairs to factor completely.